Noah, can you hear me loud and clear? I can hear you. Okay. So give me some updates, Noah. How are you? How have you been doing?
Not much has been going on.
Is that good or bad?
Quite good.
Good. I like relaxing times. Good, good, good. But really, no updates. Just normal stuff.
Just finished the integration.
Finish integration. What does that mean?
The basic part we finished.
The basic. Okay. So like you mean no application yet, is it?
No applications yet. Yeah.
Understand. Right. Remind me again. Have you sent me any topic? Oh wait, no, that's Michael. Have you sent me any topics for the mid-year?
Yeah. For AMF.
For email without. Oh yeah. There you go. Yeah. Good. Yeah. There you go. Integration until integration of power. So in your topic that you mentioned to me, you say integration until integration of power functions.
Yeah.
Does that mean that we have finished that?
Yeah. The teacher is focusing on O levels, so just continue on.
So you're saying that you will have more topics, but not tested for mid-year lah.
Sorry?
Is that correct? So you'll have more topics to learn, but the topic for mid-year only stop until the integration, the one that you just finished. Okay, all right. Okay. Good. Right. So any questions on your homeworks then?
EMF, can I ask?
Yes, of course you can ask.
Okay. Yeah, I have some.
Yeah, you have a lot of trigonometry. Yeah, you have a lot of. In fact, all your trigonometry is in the math, in the mid-year. Oh yeah. Yes. Please ask your email question.
Okay, but hang on for a while because I need to set up for a moment.
Sure. Mike, yes. Can you hear me loud and clear?
Yep.
Okay, I can hear you loud and clear also. Okay. Michael, how have you been doing? How are you?
I guess I'm fine.
Sounds good. Nothing surprising, nothing too exciting is happening.
No, I mean we're starting alkene.
There's that, yeah, and you must be hearing things like cracking and all those stuff.
Cracking, not yet.
Not yet, probably, right. We have been studying organic chemistry even more than alkene. We're just summarizing it back then. So, do you feel that you can understand your chemistry class better right now?
Well, I have to wait and see because we're not like too far in.
Are you sensing any changes, or you're still don't know?
Don't know.
Right, we'll see lah. Yeah. Right. But if things are not improving, please tell me lah. If things are improving, also tell me lah. Right. Share the good news and the bad news. Then, all right. Any other updates in terms of subjects lah?
I don't think so.
All right. Okay. So Noah, this is the question, right? This one, right? Okay, you're asking for M, is it?
Yeah.
Okay, let me see here. So green is cars. Okay, right. Okay, right. Okay, so um, like let me clarify first. Do you have no idea at all? Is it?
Yeah.
Okay. Now look at the table. There's green, red, living thing, non-living thing, right? There is only one unknown, which is the red non-living thing. Now, my question to you is this. Why is there anything else beyond the table? For example, is there a different color? Or is there something else beside the living thing, non-living thing?
No.
Okay, you're very sure. In this situation, there is nothing else. There's only 4 combinations.
Yeah.
All right, that's my first hint already. No idea?
No.
Right. Now, the 4 combinations, yes, you're saying?
Is it just 1 minus all of that or something else?
Okay, well, why is that correct? If this is all the combination, if this is all you're saying, the total probability, can it be 1 or more than 1 or less than 1 or depends?
1.
Must it be always 1 if this is all the probability?
Yeah.
Okay, that makes sense to you, yeah?
Yeah.
Okay, I think you already know the answer. Okay.
Oh, so it's okay.
1 minus everything because this is the all. Okay, so next question. I mean, you do this, then next question. All right. Okay, no. Oh, you're meeting Noah 17. Okay, so we'll try something new, Noah. We'll try to use the old Jamboard, and I'm going to rename it. Right, the old Jamboard was 10.4 and then 17.4. So let's go to the Jamboard. So we'll reduce the number of Jamboard. Michael, same thing to you. We're gonna reuse the last week's Jamboard by doing this. So by adding a date to it. So let's go to the last week's Jamboard. So Michael, do you have questions for homework? I renamed it already, so you can just go in. Do you have questions for homework, Michael?
I mean, I'm doing some right now.
Okay, but you haven't encountered any question?
Right now, no.
All right. Is that a good news, meaning, oh yeah, everything can be done? Or is that a bad news, like, oh, I haven't done much?
I think is I haven't done much.
Okay. Still, you have 40 minutes, okay? 40 minutes to hunt for questions. Questions, meaning difficult things that you may want to ask me. All right? So prioritize the harder things. But please show the video though, because I'm not seeing your video. Prioritize the harder one, please, so that we can make use of the tuition well. Right? Then after that, we can prepare for mid-year.
Yes.
Okay, Noah, is this your next question? Sorry.
Wait, before asking, until what time can I ask all these questions, homework questions?
Let's try 40 minutes first, and then we'll see from there. Right?
Okay.
So again, if you have honest questions that you already know you want to ask, just ask, right? That will be a good use of time.
I guess.
Plot this and that. What homework is that, Michael?
Physics.
Physics, right? Okay, right. So Noah, is this your question?
Yeah.
Okay, so let me see. Okay, okay, right. So feels like more like a primary school question. Doesn't mean that it's easy, but it feels more like that, right? So are you saying that you have you are not sure how to start?
Yeah.
Right. Okay. So I'll give you a few hints. Oh, there you go. Right. Okay. So now I can write something. Right. Okay. So water and syrup, and then the volume of the water, I have no idea. The volume of the syrup, I also have no idea. Why do I say volume? Because he ended up mentioning an addition to the volume of water. So volume of water I added, right? So, but initially I do not know the volume of the water and I do not know the volume of syrup. So that gives it that makes it a little bit challenging, right? Now, here's my hint to you.
Yeah.
18.7, 17.3, it seems that everything changed, but actually no. One guy, one volume, so to speak, one volume did not change from here to here. Who is that guy?
The syrup.
Volume of the syrup. Even though it seems like
Right.
7 to 3, it changes, but actually the volume doesn't change at all. Right?
Yeah.
That's a very important fact that you should work on. Is that enough hit to start something?
No.
Mm-hmm.
For me, that's the only thing I knew.
Right. And usually that would be enough for this question. Yeah. So, okay. Again, the volume of water did changes. So we probably shouldn't start from there. Now, the volume of syrup does not change, but 7 to 3 seems to change. So, you know what? Why don't we make it such that 7 and 3 no longer seem like it's changing? That's my second hint.
Okay.
Right. Show me what you can do. And then let me type. So Michael, this is drawing a graph. Normally drawing a graph wouldn't be considered too difficult, but it is time consuming and it requires attention to detail. Is there something special or difficult in this graph drawing such that you want to do it right now?
It's not the graph or the graph. Oh wait, actually, yeah, I think it's the graph also.
So what's so special?
And how do you draw? It says okay on the grid plot a graph of 1 over this against 1 over this.
Okay, sure.
How do you draw that?
If you say plot, that means they give you some data already. So can you at least show me some data?
Yeah.
Oh, okay. This data seems to be like this data you make yourself, is it? Or
It's a practical.
So you collect yourself. Okay. So when I look at this table, it feels like the table on the right side already have 1 over and 1 over. It feels like, am I correct?
Yeah.
So is that 1 over they tell you or what? They tell you to do it.
Yeah.
Okay. Then any chance that this 1 over and 1 over is what they ask in the graph drawing?
Yeah.
Then you have everything you need already. What? No, mate?
Yeah, but I don't know how to what is it? Plot it, like how do I plot the two graphs? Like how do I even like
two graphs? Plot? What do you mean by two graphs? Show me what you mean.
Sorry, it says plot 1 over whatever against 1 over whatever.
So a graph, right? A graph, right? So you're supposed to plot one graph of this against that. So let's wait for a while. Your problem might not be physics, your problem might be simply English. When they say plot a graph of this against that, there's a standard understanding. The first guy will be something against the second guy will be something. The first guy will definitely be that something, and the second guy will be that something. What is that something? The first guy. The first guy will be who against the second guy will be who. Am I making any sense here?
Right now, for me, no.
I don't like it. You have been plotting graphs for maybe 2 years already. 2 to 3, almost 3 years. The first guy will be the y-axis. The second guy will be the x-axis. That's standard sentence. Do you know this or not?
No.
I don't like it that you don't know. You have been doing this since the EMAT side. The EMAT side, you have been plotting a lot. The linear logic in EMAT, you also been plotting. Let me repeat this. This is standard. Every graph plotting sentence will mean that the first guy y-axis, the second guy x-axis. Are you clear?
Okay. Yeah.
Right. Okay. This is not going to change with other graph plotting, no matter what the subject is. Okay, so look at you, Noah. You're equating the 21 to 21. Sounds very good. And then there's yeah. Looks good to me, right? Okay, does this make sense? This is now your primary school coming back. Obviously, your primary school is quite good, isn't it? Right. Okay, next question.
Usually the lower side things.
You were saying? So,
No.
I mean, if this is something that you need for your mid-year, that means your practice is good lah. Doesn't matter whether it's a lower sec or upper sec. I mean, sec 1 doesn't mean it's easy. Definitely not. Again, Mike, this graph drawing is going to be time consuming. You need at least 15 minutes to draw it properly. Are you sure this is the best thing you can do? Are you sure? Intuition?
I mean, I'm nothing else.
There is nothing else. There is no other homework besides this thing.
I believe not. No.
All right. Then do this. Okay, fine. All right, let's do it. Yeah. I was under the impression that you haven't done much.
I mean, there's English, but I already did that. So
Sounds good. Like that. Noah, the way you start is wrong. I know this is sec 2 but you're a bit rusty.
Okay.
Right? So copy. Let me copy. Okay, still the same page, which is page 4, in the Jamboard. Are you at page 4 of the Jamboard?
Yeah.
Okay. So the part which is wrong is either this part or this part. When you read this sentence, this is not x is equal. It's not equal, It's not x is equal to the cube root of y, but it is inversely proportional. So there's something missing here. First hint. Any idea?
How do you write the thing? Next.
No, you have two options. First of all, it is not equal. So you can only write like that. This usually works in physics. Or like that. Yeah, that's fine. But what you want usually in the math is maybe, I'm guessing this is what you want. I don't know what exactly that you want, but maybe this is what you need the k.
Yeah.
You need the k. So you're missing the k, or you cannot write equal. There is a k there to be found, so to speak. So either one works fine. You will change your method. Okay, so you choose a method without k. That's fine if you know how to do it. This is my preferred method also. But if you forget, just tell me and I'll jog your memory. You probably haven't been doing this for a long time.
Yeah.
Okay, so this is the non-k value, the non-k method here.
Okay.
The non-k method
Okay.
can even ignore this. The non-k method requires very little thing. So some people will consider it very powerful. Some people will consider it very confusing. So let's see which one it is. Now, this is the non-k method. Non-k method, right? So find the new value of x when this value of y decreases by 87.5%. Now, I'm going to simplify this first to make my life easier. Can you please press the calculator and confirm that this is 7/8? (87.5% is 7/8. I'm asking you to confirm that, please.
Yeah.
Okay, so I like 7/8 more. If you don't like it, you don't have to. I like it better, so I'm gonna. Now, the second thing is when I read this, the value of y decreases by 7/8. I wonder what that means. Well, it can mean something like this. Observe, it can mean something like this. The y2 or the new y. Y2 or the new y. over the y2 or the old y. Now, I'm going to ask you a question here first. Do you prefer this to be new and old or 2 and 1? That's up to you, no problem.
Okay.
Which one do you want? That's up to you.
New and old.
Okay, so y new over y old. All right, y new over y old. Or let me put it this way first. Let me put it in the simplest way first. Y new ratio y old. Now, can you write down the ratio based on this part lah, based on this? Can you do that?
Okay.
What is it? What is the ratio based on that? Do you know how to?
1/8 over 1.
1/8 over 1. I think I agree with you totally. So the new one is only 1/8 by 1. So this will be 1:8 lah, to put it simple. Okay?
Yeah.
Okay. So just in preparation for later, I can also write down y new over y old equals to 1/8. Something like that. I can do that also. Can you? So far so good?
Okay.
Now, before we continue, Mike, are you okay or not? I'm not seeing a lot of progress. Are you okay or not?
Yeah.
Is the scale giving you problem? Because I see the numbers are very close to each other.
No.
You sure? Huh? All right. This is testing your graph drawing ability. I'm pretty sure. Let's see how it is. Now, what he wants is this. What he wants, first thing first, I have to know my x new over my x old. Keeping it simple.
Okay.
He gives me my y new over y old. I need to find this, and then I can use the x. I can use the x later on. So it's not that this 6 is useless, but later, only at the end, then we can use it, right? So I need the ratio here. So I need to find this guy from this guy by using this guy. One more time, I need to find this guy from this guy by using this guy. So I'm going to use this right now, right? So this is how I'm going to write down. Now, x new will be proportional to 1/√3 y new. That simply makes sense. Would that be okay?
Yeah. Yeah.
XO will also be proportional to what?
1/√3 XO.
XO. This simply YO. So this simply makes sense. Now, here's the secret. Without using K, I can X new over XO. I can simply do that. And it will be automatically equal to this over that. So this will disappear, this disappear. Do you understand this or not? If not, let me explain to you.
Is there a reason why?
Yes, there is a reason why. Now, let me try to show it to you. Remember that originally there is no equal. Now I'm going to put the equal sign. The requirement for equal sign is that you must put K here, right? The requirement for equal sign is that you must put K here. Again, that's the K method. The K method starts with the X equals to K over that. That's probably something you memorize. Is this okay first or not?
Yeah.
All right. So these two equal sign can just be one. So far, so good. X new over X old is this guy over that guy. So far, so good.
Yeah.
Notice that the K, by its nature, is not K new and K old. Do you know why?
It's a constant.
Yeah, so the constant doesn't become new, doesn't become old. It just stays the same. Because of the division, they both simply cancel each other. So it's 1 and 1. The K disappear, so to speak, because they are canceled. It always happens. As a result, you no longer need to worry about the K. Does that make sense just now?
Yeah.
All right. Now, if you've already written this, you're on the right track already. Now, can you proceed from here and using this one also so that you can get this one? Can you proceed by yourself or do you need more help?
Do I use 1 and 8 or some other?
You need to 1/8, but it's not ready to be used right now. You still have this problem. There's some manipulation needed to deal with this? This is the question. Can you deal with this or not, so that you can use this? Can or cannot? What?
Cannot.
Right. Now let me show you the easiest way. The easiest way, yeah. The easiest way is you will replace this by 1. And you will replace this by 8. 1, 8. This is not exactly true because this is 1 unit over 8 unit. Actually, it should have been the case. Understand? Later on, the unit will cancel each other. So in the end, you are left with 1 and 8 in the end, because the unit did cancel each other. Okay? So now you have on top 1 over root 3, 1, then over 1 over root 3, 8. Then all this will be your x new over x old, which is something that you need later on. Can you now find the x new over x old?
Okay.
Okay, please do that.
But what do I do after that?
Please go and find it first.
Okay.
Michael, are you okay so far? Oh, you have drawn a line which went through 2 points and did not went through 3 points. Am I correct?
Yeah, just draw best
fit line, right? Now a best fit line doesn't fit as many points on the line. That's not what it means. A best fit line means construct a line which is closest to everybody.
Yeah.
Now, are you sure this is the best fit line? Because the way I see it, your line is very close to 2 points. That might be good, but therefore not so close to 3 points.
Yeah.
Are you sure that you cannot take a better middle ground kind of thing, maybe?
I think I need to redraw. I might need to redraw.
Maybe only the line. Now, second thing.
No, I think I need to redraw it because what's it? Like the value I put here is like too high per se. Because I started from like 1 to 5, right? But they want the intercept of y-axis.
Right. Now, this is something that bothers me a lot. What bothers me is this. You draw the line, then you realize. It bothers me a lot. I was wondering whether you could have predicted this before drawing, and therefore in exam, you will be saving time. Is it possible? Or the only way for you right now is to draw first, then see what happens.
I think it's possible.
It's possible because that's not a bonus skill, at least for me. This is not a bonus skill. This is like a required skill, I feel. Now, there's a second skill so that you don't waste time because we don't have a lot of time. There's a second skill involved here. Notice that from 4 to everything is empty, correct? You can actually save by truncating the y-axis in this case. There's a formal way of doing it. I don't have to draw from 0 to 4. I can directly jump to 5, for example, so to speak. As a truncation, there's a truncation of the axis. Do you know what I'm saying here?
Yeah.
If you know what I'm saying, then you are drawing
I know what you're saying, but like, I didn't like think at the moment.
And you are not truncating it. You are just shortening the scale, right? You're just making the scale smaller. I feel that that's not the best skill at all, because then you're making the line less gradient, which is probably not what you want. That's my guess. My guess that's not what you want. I feel that the truncation method
So
is
can I
much
do
better.
bottom 3, and this is 4, and this is 5?
I think go more ambitious lah. Just go from 4 lah. I feel, right? Because you can just see the point of will it go lower than 4? No, right? So just start from 4 lah. Because my guess is that your y intercept will be around 7 or 8. So I think that's fine lah. Now, what's the formal sign of the truncated axis?
Formal sign.
Oh dear, your drawing. So look at your Jamboard, page 2. Have you ever seen this before? This is the like something like that. This is truncating the axis lah, so that you can go from 0 and suddenly jump to 3, so to speak lah.
Oh,
You should be doing that currently lah. You cannot just jump without saying it out. Basically, this is how you say it lah. This is how you say it. Okay.
it's a 2-line thing.
Yeah, something like that.
Like this.
Something like that. So far, something. Right. So far. Right. Now, secondly, your points are very suspicious. Let me show why. Your points look like that. This is like super horizontal to each. They are very suspicious. Usually points are not like this one. They're super suspicious. Are you sure your data or your very suspicious? Very weird. Please check it out.
It is. The data is correct.
Okay. I find it very weird
Because
though.
is the thing at the bottom, right? Is 1 over the average of two things, and then if the average is like the same, then it's like, then what else? It's like if the average
You
is
will
the
be
same,
horizontal. Yeah. Still very suspicious. But okay. We'll do what we can. Sure thing. Now, Noah, how are you?
sorry, God.
Yes.
Really quick, can I just head over to the bathroom?
Sure thing. Be quick. Yeah. All right. Noah, I cannot follow your working. I cannot follow your working. Noah, your answer is the x new over xo is 8 over 1. That's your answer. You didn't use the root 3 at all. The root 3 doesn't matter.
Oh.
And you're also not writing this, which then it feels that this approach is like, it feels new to you. It feels like you're not writing this. You're not writing the root 3. Right. No. Very bad. Yeah, very bad. If it is new, later tell me, because it does feel new to you. It does feel like that. Let me see your working. Let me see your working. Now, you also didn't write y new and y old, which is, again, very important because you made a mistake. Because you didn't write the y new and y old, I feel that that's why you make a mistake. Write down the y new and the y old, and then figure out the mistake, please.
But then the evidence like so weak one.
Now, do you see the mistake?
Yeah.
Right. Okay. So please correct it.
Yes. Teacher not suspicious at all. Wait, x is new over old for both, right?
If x is x new, the y must be
Y new.
Makes sense, right?
Yeah.
All right. Just now you put y new as 8, you know, just now lah. That part is the part that I feel is wrong lah.
Okay. It's not a 10-finger dash.
Move up, please. No, move up. Okay. Okay. Now using calculator, you arrive at this answer. So this answer is at least different from 8/1. Don't know whether that's correct or not, but we have an answer, 2/1. Now, time to use 6. Right? X equals to 6. Now, what do you think? Is X equals to 6 the new guy, the old guy, or something else?
Old.
The old guy. I will agree with you. So can you find the new X lah, basically, right? Right. Now, for now, we need to kindly check the answer key first, see whether you're correct or not.
This is the answer. Oh, yeah.
This is the answer. Is it correct? Have you checked the
There's no
answer key?
answer sheet.
There is no answer
There's no
sheet.
answer key.
There's no answer key. So let's say that this is the correct answer. We don't know yet. Right? We don't know yet. Now, is this a new method? Does this feel comfortable to you?
In low sec, I usually skip this chapter.
I will understand that.
It.
Yeah, I can understand that. Now, what do you want to do for O level?
Get the marks from these questions.
Get full mark, get half mark, get
Full.
as many as mark possible. Full is it?
Yeah.
So we have time, right? Before O level, we have a lot of time. So this is the first method lah, the method that doesn't involve K lah, right? So there is a method that involves K. Now let me tell you the downside first. The downside of method that involve K is that sometimes the question just doesn't give you enough information to find K. That means the question forces you to skip the K method. And if you don't know how to do it, then you have to skip the question entirely.
Okay.
But some questions do give you enough information to find K. Let's see whether this question gives you enough information or not. Okay, so that's the first thing you must ask. Okay, if you like the K method after I show you, you must still be very careful. Whereas this method, because it skips K, it will work for whether the easy question or the hard question. Make sense, yeah? Right? Yeah. Now, so let's see whether this thing can find K.
But does this not fit?
Sorry, you're saying?
Helpful for.
Sorry, you're saying?
Helpful for even the harder questions.
Oh, the hardest method. This is the best method.
Okay.
This method works every time, so to speak, like the hard and the easy. Okay, so there's the upside of this method. Every method has an upside and downside, right? Okay, so now in the K method, our goal is to find the K first, because that makes our it makes us feel better lah. Hey, we found the K. So we must start with X equals to K over root 3y. Now, any problem first with this? We must start with that lah.
Okay.
Okay. Now, how do we know whether the question gives us? So the question will give us enough if they give us some sort of X together with some sort of Y. Does the question give you that? No, yeah? No. So the question only gives you 6 here. we will never be able to find k because they never give us the y. He say a particular value. Can you? So I will now give you a method to bypass that problem. This is a problem. It can be bypassed. It can be bypassed. Okay. So I will now show you the bypass. However, this bypass might feel weird also, the same as the previous method. The previous method seems new to you. It might feel weird. So this bypass might actually make it feel weird also, right? So let's see what happens. So here's the bypass. The bypass is like, okay, I need y. So I'm going to assume, now first of all, remember that this is xo. Still the same thing. So this is yo, right? So I'm going to assume yo is simply equal to 1. As simple as that. Okay, can? We're just going to assume that. So I can find k. Now what is k? Noah, what is k?
6.
Right, 6. Now, the question continues. I'm supposed to find x new, but well, the question actually tells you y new. You have to realize that also, right? The question actually tells you y new, okay, by saying that the value of y decreases by this much. So since we are assuming that y over 1, we can now find y new first.
Okay.
Okay, so what is the y new? What is the y new? You must go and find it first. If you're stuck, tell me, Noah.
Is it the 1/8 thing then?
We still need to use that, yes. We still need to use that, yes. That one is not new. That's why it's not a different method. Every method will need to use that. I suppose so far so good, Mike. I suppose you did find the intercept, right? Right. I don't make the graph, but what to do, right? The data is like that. So Noah, what is y new?
Not sure.
You already have it. Now this bothers me. This bothers me a lot because this is from primary school. Look at the first line, y new ratio yo, right? You write 1/8 ratio 1. I was very happy because you are correct. That's correct, right? Then it becomes 1/8. That's just simple ratio simplification, right? Now, currently we're assuming that yo is 1. So what's the y new?
8.
What is it? What is, if yo is 1, y new is?
8, is it?
Does that make sense?
Yeah.
Y new ratio yo is?
1/8.
1/8, right? Who's bigger?
Y new.
Come on, wait, no, think carefully, please. You're not thinking straight here.
1 unit, y old is 8 units.
So who is bigger?
Old.
Okay, so just now you say if the yo is 1, the y new is 8. Does that make sense?
Yeah.
No, you're not thinking straight.
Wait.
You're not thinking straight, Noah.
Old is 8 units, right?
Oh, okay. Old is 8 unit, new is 1 unit, right?
Yeah.
So if yo is 1, the value of yo is 1. The value of y new is 8. That's what you said. Does that make sense?
No.
Okay, so if the yo value is 1, what is the value of y new?
1/8.
Okay, does that make sense?
Yeah.
Okay, now in your k method, you have k And you also have the y new. You cannot escape lah. You have y old, you have k, you have y new. Now, since you have k and y new, can you find x new?
Yeah.
Okay, please give it a try. All right, so voila, done. Okay.
Okay.
Right, so you have the non-k method, you have the k method. Both can navigate through the hard questions lah. Right, they just have a different way of doing it. Which one would you choose to practice for the same question next time?
The other method is that's not the K method.
So you're saying that the first method, that's what you're saying?
Yeah.
All right, so I want you to dog ear this page so that next time you can find it again. Do you know what's dog earing? All right, you just fold the thing. Okay. Right. Okay. So next question, please, Noah. I think we still have to do homework. You have homework. Michael also have to finish. So, I like it because you're preparing for mid-year. This is preparing for mid-year, right? No?
Yeah.
All right. So good. So good. That's good. I like it. So no problem. Okay, Michael. Yep. All the gradients stuff. Yeah, this is weird because it's a focal length. Yeah. Yeah.
Justice.
Okay. Now, is there a question or you just want to try first?
The question.
Okay. Let me ask a question first before we do this. Is this the hardest question you have been practicing so far in integration? That means, is this part of your mid-year? That's what I mean, actually.
Yeah.
Oh, wow. So you will recognize this, right? This is the differentiate after integrate. And they ask you to differentiate because they're trying to give you a hint. This is like what we discussed, Simon. So the differentiation part is usually always the one. So let me see your differentiation first. Then let's do the part 2, right? Let's see whether we can pick up the hint. Okay, now I know that you will be tested until here. Good. This usually yields a lot of marks in exam. So that's not bad. It's not bad. Like it. Show me your differentiation. Michael, are you okay so far? Maybe with part F, is it?
Yeah.
How's part F for you? I cannot see a lot. Please pull up. Yeah. Okay. Yeah. Okay. Right. So, are you stuck with part F?
Kinda.
Right. Now, tell me what you're stuck with, like the picture, the sentence. You don't understand something.
So, like, was it?
Which practical are you talking about? Practical. It's not that one, right?
So it's like, what? How do I draw the object? Because like, okay, I put the object here as the arrow thing, right? Then I draw the straight line to here, and then it goes directs down. And then what? The object here, and then it goes like down here or something.
Okay, before you do that, I can clarify with you. Before you do that, where is the object actually? Because this
Also the okay, it's not an object actually. It's like they have a torch light, right? And then they
okay,
like
okay,
wait, let me just try to draw something. They have a torchlight here.
okay, okay, right, okay,
Then
right.
on the torchlight it's like a cross wire in the shape of like this. It's like an X. It's like a circle and an X. And then
Okay, okay,
they arrange it so that it's like against a meter rule, and it's like 90 degrees to the meter rule. And then
right.
they have like this
Sorry,
screen.
Noah, do something first. Don't do something else first, if you can. Don't wait for me.
Okay.
Never wait for me. Right. Yeah, Michael. Yeah, sorry, you're saying.
Then they have like this screen thing over here, like over here. It's still 90 degrees to that thing, and then
And then,
basically
okay,
this X is on that thing, and you have to put a lens on in the
in the
middle
middle,
because
and
the light
then
is not strong enough. Then put a lens in the middle, then you adjust it to so that the image is clear on the screen, like as clear as it can possibly be.
you're saying that the X image is clear.
Yeah,
The
yeah,
X image.
yeah. So there's one
So,
here, and then there's one here. It's like the one here is like magnified, and the one here is diminished.
so that's what you found from the, and the position is quite clear, right? Okay, I
Yeah,
like it. Now, my question is, in the picture, how come in front of the lamp there's like a wall like that? How come? What is that wall?
the wall. Oh,
What is that?
I think this is was it? I think this might be what the original experiment was. Like, and then the exit thing is here.
Like you're
I
just
think.
shining an X sign using a strong lamp, something like that.
Yeah.
So
Something like that.
basically the same, just very similar to what you were doing.
I mean, it will be weird if it's not.
I suppose. Okay, I understand. I understand what you're saying. Right. So there is no object. Wrong. There is an object. The object is, so to speak, starting at the wall, which is an X sign. Correct? Right?
Yeah. Yeah.
And then this X is slightly behind the F. Because that's important. It's behind the F. It's not exactly on the F. Am I correct?
Yeah. Yeah.
Oh, this is important. So we have an object. Just to be clear, we have an object, right? The focal point. So draw a array diagram to show the focal. Okay, great. I'm gonna take a picture of that. Now we haven't discussed about this much, yeah. So hopefully we can clarify something. Noah, you okay? You're doing something else, right?
Yeah.
Okay, good. Right. So, Michael, you're mentioning so here's the lens, right? Here's the lens. You're mentioning, you should be mentioning the three useful rays to use lah. The first ray is like that, correct? Just go through straight. That's the first useful ray. The second useful ray is parallel, and then you will go through the F, right? That's the second useful ray. The third useful ray is that it goes through the F here, and then it goes like that. Okay.
Okay.
So these three useful rays are useful because they are predictable. There are many other rays. There are rays in between, the rays which is not parallel and which does not go through the F. This thing will also do something, but it's very difficult to predict. So that's why we don't use them. The rays exist, but only these three rays are very useful or easy to use. Understand?
Yeah.
Right. So watch it. The object, interestingly, the object should be seen as, because usually when you draw an object, you will draw it from the top to the line, right? Usually you will do that. Usually you will not draw an object across the line. So what I'm trying to say is, this, I'll make it clear first, this should be seen as two objects.
Wait,
Two
are you
objects
drawing something?
on the Jamboard page 5.
Page 5?
We are at page, oh, I'm sorry, I draw it at Noah's Jamboard. That's my mistake, right? I'm so sorry, that's my mistake, right? Now, next time you send something weird, please say it in. That was my mistake, right? That was my mistake. I've been drawing. Okay, move to page 3, please, Michael.
Yeah.
Sorry, let me just delete this one once, please, to make it confusing. Right, so Michael, right here are the three arrows. Again, if you sense me doing something and I'm supposed to be drawing something, I draw a lot, right? So like I was drawing this. If you sense that, how come you're not seeing anything? Just say it at the start, okay?
Okay. Yeah.
Okay. So here's are the three useful rays, right? The one that goes straight here, that's one.
Yeah.
The goes that go parallel to the line and then go to the focus, then parallel to line. These are the three useful things. The one in the one in between are not very useful, but they exist. Okay, now focus on the object. The object usually is drawn from the top of the object here to the line only. You usually never cross the middle line. So I'll consider this X, so to speak, as two objects. One top half here and bottom half. They are two objects, even though they are just mirror image. They are two objects, right? So I'm going to handle the first object first, and then that will make the second object, I think, very easy to use. Now, which useful ray do I use? I'll label this the first ray. I'll label this the second ray. I'll label this the third ray, right? Which one?
The first one.
The first one. So we go straight, and then we go through the focal point. There you go. Right, and then I don't know where we go. We just do. Then we need two rays in order to form an intersection in order to be able to draw it. So where is it? Which other ray should you be using? Second or third?
The third. No, wait. Yeah, the third one.
Okay, let's use the third one. So I'm not. You have to draw. We have to draw very accurately. Huh? I cannot, so I'll just draw that. I have to go to the focus, and suddenly I don't think I'll be touching the lens. So it's a bit of a problem.
So right. The second one.
All right, so let's try the second one. So the second one will be going through the center like that, and then going through like that, and then maybe it will be here. Maybe you have to do an accurate drawing. Understand?
Okay.
So that's my first half of the object. Now tell me, the second half, which is in green, is it going to be that difficult?
The second half of the object,
the green
no.
One. Yeah, I think it'll probably be at the same place and drawn like that. I think probably correct?
Yeah.
Right. So maybe this is what he's trying to ask you to do. He's trying to ask you to draw a ray diagram to show the formation of the image. If you're trying to form an image, you must have an object. There's your object. This is the image. These are the ray diagrams. You need to draw one for the top half and one from the bottom half. You need to draw both. Okay, please give it a try.
Yeah.
I don't know where you're supposed to draw it. Is it here or else? You must draw something. And it must be accurate.
It's on here.
Yeah, so it must be accurate, yeah. All right, so Noah, I'm ready to answer your question. Right. Show me your working first. Sorry, let me copy this first. Let me copy this. Oh my goodness, the connection today not so good. It's very blurry. Oh, come on, make it nicer. Never mind, I don't want to wait. Okay, show me your working, Noah. I'm at page 5, yeah. So you will see that the thing is very blurry. So I need your help to ascertain it. Okay, so you see that my screenshot is very blurry because the connection is not so good right now. So let me confirm what this is. This must be 5x squared ln x, correct?
Yeah.
And this is 4x ln x, correct?
Yeah.
Okay. Now integrating this, we cannot. Why? We cannot integrate this. Why?
Because of the long x.
No. Say it very clearly. This is times. We don't have product rule for integration.
There's no rule.
Yeah, there's no product. So we cannot do this. We must use the hint they give us. So the hint will convert this from impossible. I mean, this is impossible into something that is probably doable. The hint. Now, the hint goes like this. This one. right? I have this. So currently I have this, and let me just confirm that this is correct first. So you're using the product rule. Of course, for differentiation, you have product rule. This is great. This is great. So yeah, u prime v is called, wait. Yeah, u prime v, and then u v prime is correct. Okay, good. So let's say this is correct. Now, how does this help us with that? I can already see it. So it's a matter of, hey, yeah, this thing is definitely going to help me do this. Do you see it or not?
No.
Okay, then repeat what I'm doing and then try to understand what, right? Now, this is what I'm going to do. I am going to integrate left-hand side and right-hand side. The hint, I'm going to integrate this and I'm going to integrate everything here. I'm integrating the left-hand side and the right-hand side. Make sense so far?
Okay.
Right. Now, remember what I told you. Integration meet differentiation. What happened?
It's the normal thing.
So it becomes nothing. You're left with this guy on the left-hand side. Make sense?
Yeah.
Now, what happens on the right-hand side? The integration sign did not disappear. Why?
Because that's equal.
Because it's just there's no
integration
differentiation. There's no differentiation. So the integration stays.
Okay.
Make sense? Okay. So
Yeah.
integrating 10x ln x lah. And don't forget, I can split it to integration of 5x. And don't forget, we have to add the x here and the x there. Would that be okay so far? Right? Yeah? So this one, one makes sense. Yeah. Now, I'm not seeing 4x ln x here. I'm not seeing it here. But I'm very comfortable. Do you know why?
Move things around.
Actually, no. Again, I hope you can see this. So now, integrating this is easy, right? What is it? What is it?
5
integrating
over 2 x squared.
Good. Something easy for you. And then again, here's 5x squared ln x. And then again, we're left with this type. Notice that again, we cannot integrate this here. Because why?
Yeah.
There is no product rule for integration. But I'm very comfortable because I look at this and I look at that. Are you getting the hint or not? If you're not getting the hint, then I have to do it for you, I suppose. Do you get it? Do you get the hint?
Divide.
Sorry, Noah, what is it?
You divide.
You mean this is 10 and this is 4? Is that what you mean? You have to adjust something?
Yeah. The 10 divided by 5 over
4. And how do you do that properly? I want to see you do it properly. And if you can do that, you're almost done already.
What do you mean do properly?
In this case, I have to do it for you first, right? I need to change the 10 to 4. That's not, you have to do it properly. So let me just rewrite this first. Just rewrite this as this. So integration of 10x ln x dx equals to 5x squared ln x minus 5 over 2x squared. So far, so good?
Oh, okay.
Right? I need, however, 4x ln x, right? I need 4x ln x dx integration. So 10 is my problem. I just put it inside, right? So how do I adjust the 10 properly to the 4? How do I do that?
Times.
You use Dodora, but just to be clear, I was hoping to hear Dodora. So times 4 over 10, right? And then this everything also times 4 over 10. If you do that, you will get this, and the answer here will be correct. No? Do you understand?
Oh, okay.
Right. Now, do you see how the hint is part A, right? How the A makes B into something possible.
Yeah.
Right. You don't have to do the integration directly. You're actually doing it very indirectly, basically. Now, try to rewrite this and see whether everything makes sense to you, right? Please try and do it slowly, okay? Right. Okay, so Michael, sorry.
Yeah.
I cannot, because it's very blurry. The connection is very bad. Yes.
Do I draw the light being refracted at the line in the middle?
Sorry. Oh, in the middle. this is a rule is in the middle, not at the not at the interface. It's at the middle.
Because it almost intercepts, but it doesn't intercept at the redraw it.
Right. You should draw it at the middle. No time to explain, but in the middle. So we are pretending the lens doesn't exist. You're pretending, yeah. You're pretending. But that's the right thing to do. So no, I cannot follow you, but you just show me when you're done. So you're saying that it almost intercept at the screen, is it? It almost as if, so I don't think that's a coincidence, right? I think that's probably they meant it to be. Minus x squared, right? Yeah. Okay. So Noah, are you clear with the steps?
Yeah.
Right. Now let me state one thing. Let me just state one thing for understanding purpose. You never actually integrate this. You just integrate this guy and this easy guy. You never actually touch this guy. Do you understand?
Yeah.
You avoided the problem entirely by doing something else, which is easier. You're trading something impossible with something doable, and you got the answer. Still correct, look. You understand this?
Yeah.
Okay, this is always the method for this kind of question. Always. Meaning to say, you have no chance, but you must use the hint from part A. You must always do that.
Okay.
The good news is using it is not very difficult if you understand how, which is this one. Right? So if you like this, because it seems that you can do it. Right? If you like this, you can practice a few more and expect this to happen in exam.
Okay, but I got a question.
Yes.
For this one, is it because
I cannot see anything? You're pointing.
Okay.
Michael, you need to do another one, a very similar ray diagram for the bottom object, okay? Bottom half. You need to do that also. Okay.
Really?
Yes,
I thought it was only one.
Look, I told you the object must be seen as two objects because usually an object goes from top to the middle line. This object crosses the middle line, so it's like two objects.
Okay.
Yeah. So yes, Noah, you're saying?
This one.
I cannot see what you're pointing at. I cannot see. Maybe you zoom out a bit.
You so much. Oh, the Jamboard.
Ah, the Jamboard. So you're saying yes, Noah?
For this one.
For that one, you're saying yes. What is it?
Door or something wrong.
Oh, it is Doldor. The Doldor is integrating both sides.
Okay.
Right, you do to the left integration, what you do to the right integration also, same thing.
Okay.
Right. Yeah, the method works. The method works most of the time.
Like for this question, it's different.
Which one? Sorry, which one?
This question one.
Question one. Okay. Are you supposed to show something? Sorry.
Wait, do I show the
Maybe
question?
you show me. Oh, okay. That would be nice. Maybe easier that way. Show me question one. Where's question one? So that's a show. Yeah, this kind of show and hands definitely, I will strongly suspect this kind of thing. Okay, so show me your working. Okay, let me copy and paste first. Looks good so far. Okay. Okay, so you have shown, right? You have shown. Okay, so the integration that they're asking you to do is very, very similar to this thing. Oh, the question is easier lah. So The question is easier. So the way you do it is excellent. The way you do it is excellent. You just indicate that you have, you go out, then this becomes exactly like this one, right? So you know that by integrating this, you will get that. So this method works, but it's because it is a simpler question. This is very close to that. You don't need fancy stuff, so to speak.
Oh, so if not so close, you do the other one.
Yeah, I mean, you can see, hey, wait, it's different, right? So you go back to page 5, right? Back to page 5. You can see that, wait a minute, this is maybe similar, but not very similar. So I expect a little bit more manipulation, right?
Okay.
I mean, it's basically almost the same, but how do I deal with this? Okay. Then I'll do my door first. I'll just do the door method is a foundational method, just door here. See what happens. Oh, I can handle this. Okay, then that's okay. Okay.
Okay.
Okay. Again, what I'm saying that you shouldn't be worried by this. You should simply handle it. Okay. Any other question? No.
No.
I'm happy with your questions, even though we are not doing a paper, because you're so continue doing if you want to. Michael, what are you doing right now?
Like the source of everything.
Okay. Before you do that, because your connection has been very bad. Is it possible to switch to 4G? I can hardly read you. See, I can hardly read since half an hour ago.
Sure, but not
now it's better. So now I can read. Identify one possible source of error. No. Okay, yeah. I mean, you're stuck here, right? You did the experiment, lah.
Yeah.
If I were to do this, I will be guessing a lot, lah, right?
So sorry, the source of error. She said it's so the image projected of the cross on the screen. It needs to be basically. She said, make sure to your best judgment is as clear as possible.
You have to use your eye to tell whether it is as focus, like, is it focus? Is it where it's focused? So you have to use a bit of judgment. So I suppose that's also a source of error. That makes a lot of sense, right?
Yeah.
Is it the improvement which is the problem?
Yeah. How do I phrase the source of error?
If that's what you want, the position of this, the position, okay, the positioning of the lens, right? The positioning of the lens determines the sharpness of the image on the screen, correct?
Yeah.
Basically, right? So the sharpness of the image of the screen is determined subjectively by our eyes.
Yeah.
So when I use the word subjective, means I admit that I am a source of error. My eye is a source of error.
Oh, okay.
I'm using my own sentence though. I feel that I'm more comfortable if you can use your own words. Like you understand what I'm saying, right? But can you say it with your own words?
Yeah.
If you can, use your own words and then let me read something. Okay, I mean, it's getting very blurry again. So, Noah, are you okay so far?
Yeah.
All right, cool.
Hello.
Yes, Michael.
Yeah, switch to data.
Okay, hopefully that's better. Okay, let's see. Seemingly better. Yeah, let's see. Yeah, seemingly better. Right? Right. So the improvement, right? So you're writing there and then how would you improve this?
Yeah.
How would you improve something which is subjective, right? The problem is this is our judgment. It's very difficult to improve our judgment. It's very difficult to improve our judgment. Okay. Right, this is impractical, but it works. So I'm going to say this because it's very difficult to improve our own judgment. We are limited that way. Like improve your stopwatch pressing skill. How am I supposed to do that? You understand what I'm saying?
Yeah.
Yeah, we frequently must use our time stopwatch, right? So back then we would improve it by just waiting for 10 repetition, for example. Then we press the stopwatch. So we don't press stopwatch for 1, we press stopwatch for 10.
Huh? Repetition.
If this makes sense to you. So
Oh wait, I think improvement is repeat the thing more.
Repeat and take
how,
average.
I mean, like, I don't know how stopwatch is included this thing.
No, stopwatch is never mind. You know that in A level. Never mind. Forget what I said. Yeah, I don't like to use repetition here because yeah, I don't think that improves the error. That's not the way to improve error for such a subjective. So currently, I cannot think much beside this impractical example. This impractical example is make the X bigger. Make the X bigger, which means you need the lens to be bigger, which means you need the screen to be bigger. But if it's a bigger thing, then it's easier to see whether it's sharper.
Okay.
So bigger object, bigger image, right? But also bigger lens, so bigger everything. That would reduce the error. But it's not practical. It's not easy to make the lens larger, right? So let's not think too much about this for now. Huh? Maybe we should go to the next question first, maybe, if there's anything else.
I mean, there's related to that though, but there's this thing I kind of still confused about this new topic.
Please do.
Is this
definitely is nicer the picture. So, sorry, what is your question? Sorry.
I have no idea what this is because I think I was not there on that day.
Oh, this is like totally blank.
Yeah.
Oh dear. Okay, this is very abstract. I'm not blaming you. This is very abstract. It's one of the most abstract physics right now. I'm gonna take a picture. I'm gonna try to explain. Mike, okay, Mike. So page 4, yeah, okay. Now, the electrostatic field lines, which you're trying to draw. Oh, you're drawing the lines of forces. Well, that's not so bad. That's actually not so. Wait. Never mind. Okay, I take that back. Now, Michael, when you draw line forces, right? When you draw line forces, it's not something that you see in real life. Like this is something like, for example, I'm pushing you. I will draw my force like that, no? That makes sense, lah. I suppose I'm pushing you to the right, correct? If I'm drawing a force that is pulling you to the right, I will draw it this way. This makes more sense than this one. This one's pushing you to the right. This one's pulling you to the right. Now, there's you don't ask for the force to appear as a line, right, in front of you, right? But the line makes sense, lah. Correct, right?
I suppose.
Right. So with that mindset, I will try to explain this electrostatic field and this line of forces. Right? Now, the line of forces, if this is truly a line of forces, first of all, it must have an arrow. If the line of force that I draw here doesn't have an arrow, suddenly it makes much less sense. Okay?
Yeah.
You would demand the arrowhead to appear because it means something. Without the arrowhead, it doesn't mean a lot. It is something missing. So in your situation, I feel that you're drawing a line, that's great. The line is equally spaced, that's nice, but that's because the question tells you, not because we understand. But I feel the clearly missing thing is the arrow. So what does the arrow mean, right?
Arrow.
Right. The arrow. The arrow can mean push or pull. Please. That's not correct. Huh? The arrow can be meaning a push or a pull. Doesn't mean that this is a push and this is a pull. As you can tell, this is a push, this is a pull. Arrow is the same. Can? So far so good.
Okay. Yeah.
The way I draw it, this becomes a pull because I draw it here. This becomes a push because I draw it here. Okay, so don't say that an arrow determines push up. That's not true. This simply means that, let me just clarify what this means. This means that you assume that you are a positive charge, not a negative charge, because I know there's such thing as negative, but I'm assuming that I'm a positive charge. And the positive charge, if I put here, for example, will experience arrow to what direction? That is how you must draw your arrowhead. So assume that you're a positive charge, and then the arrow will be like what?
If I'm this positive charge.
Yeah, if I have a positive charge flying between plate A and plate B, it doesn't have, but let's imagine. Let's imagine that. So the arrowhead
this positive charge.
Like this thing, like this guy, I just draw this positive out of nowhere. I just put it there, boom. Boom. So these lines represents the force experienced by this positive charge. But if it is a force, then we need an arrowhead. Draw an arrowhead. You have problem imagining the arrow force for there you go, 1. Now then might as well draw everything like that. Okay. Okay.
Yeah.
Okay. So now you are imagining that you are a positive charge. So the positive charge will experience this kind of line force. Now you're complete. Now you're complete. So what happens if you're a negative charge? If you're a negative charge, it doesn't make sense, right? If I'm a negative charge, I am not experiencing this force. I am not. Can you please confirm that first? I'm not experiencing that force.
Yeah.
I am experiencing actually this force. I am. Did that make sense? Right. Okay. So here's the rule, so that nobody's confused. Here's the rule. Here's the rule. If it is a negative force, if it's a negative charge you're dealing with later on, you will assume it is totally the opposite of this force line, just like that, without the need to draw. Because if you draw, it becomes extremely confusing. So you're being biased to the positive charge. You just pretend that we are just dealing with positive charge. First, if it is a negative, you just reverse everything. That's just the rule for now to prevent confusion. Too much drawing, not good. Okay?
Okay.
Yeah, so that's the first rule I want to establish. And with that, I can already explain to you, first of all, you're missing the arrowhead. You need to draw the arrowhead. Now, secondly, I want to explain what is field. So what is field? Right, so before I do that, Noah, are you okay?
Yeah.
All right, okay. Now, let me explain what field means in the best way possible. The best way possible. Field is almost force. Almost force. One more time. Almost force. What does that mean? Let me explain. Here's a positively charged plate. Here's a negatively charged plate. There is no charge in the middle. Remember, I just summoned it out of nowhere, but actually there isn't. So what you draw is not a force line, but a field line, because it is almost force. What do I mean by that? The field line which you draw only become force when you finally have a particle to interact, whether negative or positive. The moment you have a positive charge here, this field line with an arrow becomes a force line. It now makes sense. Before the existence of this charged particle, let's just put it this way, there's nothing to force it on. There's nothing to force it on. So you draw a field line, an almost force. Am I making any bit of sense right now, Michael? Let me try again. The fact that you're drawing field means you are interested in force.
Okay.
Because force is usually what matters. Now, what does field mean? Again, field means there is no force yet because there is nothing to force in yet.
Okay.
Again, what I mean by this is very simple. So, for example, here's a magnet, north and south. Without the existence of another magnet or another steel, you will not see any force, right? You will not see any force. This magnet will not force something else without the existence of this. But you still draw magnetic field lines like this, right? Correct or not? You still draw it that way, correct? Because magnetic field lines, the word field means almost force. Almost force means if only you have the thing to force, it will look like that. Look, the field will become the force. If you could just imagine the thing you are forcing there, almost force.
Okay.
Before the thing you force exists, you just imagine them, you get the field line. Field is almost force. That's what it basically means. This expresses your interest in force even before the thing being forced exists. Okay? So that's why I was telling you, imagine first a positive one, and then you can draw the force line. Then you erase the guy, and then voila, that's a field line, no? Voila, almost force. Not yet force. I don't think your teacher explained that way. I think your teacher explained you the rules. So for now, like that. You okay, Mike? You okay?
I guess.
Right. Let me now try to make it as sensible as possible. Let me try. Yeah. Here's something that you have not drawn, and here's something positive. Here's something positive, and then here's a negatively charged. Right? Now, don't draw the field line. Just draw force. Now, in order for you to draw a force, you have something else to be forced here. So, what is it? A charged particle. Is that okay, Mike? You can only force a charged particle with positive and negative. That's just how it works. Okay. Now you have summoned a charged particle. Now draw the force that he experienced. Draw the force that he experienced, please.
Force of the charged particle experience.
Yeah. Again, use your logic. Okay, nice. I totally agree with you. Now, this is a force, right? Now, if I erase the charge particle because we just summon it, then this become a field line. Let me show you another example. Now I draw it here. Draw the force line, please. Draw the force line, please. Okay, nice. I'm going to pretend that both of them are parallel. Huh? So this is supposedly a force line, but if I erase the charge particle, because I just summon it, it becomes a field line. Okay, right. Now, one more. Can I imagine a negative charge?
Yeah.
Of course you can, but for uniformity purposes, let's not do that. Because just imagine the positive charge. We are being very biased. We are being very, very biased. Please don't imagine the negative charges when you're still drawing the field line. Okay? Just stick to the positive charge. Please do that. Please draw the force. All right, I'm going to pretend that all of them are parallel because now this is a force line. And now I'm erasing the charge particle again, and then this become a field line. Like, look at this, and like this is how this came about. This process is how the field line came about by imagining the force line.
Okay.
Okay, can yeah?
Yeah.
So this makes half sense. At the very least, it makes half sense. Okay.
Yeah.
Now the equal spacing thing, right? Now, if I imagine everywhere, I suddenly realize I can draw a lot of field lines. Correct? Suddenly, yeah. Imagine. Now this is unruly. This makes no meaning. Even if I draw this one, I can still draw here also, and then I'll come up with this. I can still imagine here and come out. So this is very unruly. How packed should I draw this line? The line must have some sort of meaning. I cannot just randomly say, oh, I want to draw this pack or I want to draw this narrow. I can keep drawing or keep erasing if I want to. So far, so good. We have a problem here. Yes?
Yeah.
So they establish a rule. They establish the rule. The density of the line, something. Let me give you an example from the magnet. The density of the line means something. You would remember that the density of the magnetic line is very dense near the pole. Correct?
Okay.
Very dense near the pole. And if you go further or if you go to the side, it is less dense. Then you go to the pole back, it's dense again, right? The density means something. It means you will feel the force strongly here. If you have something to, and you will feel the force less strong here. Exactly what you experience with the magnetism. Or if you go further from the magnet, wait a minute, the lines here are less dense. I will feel it less strongly. That's the rule. Okay. So why must the line be equally spaced here? Basically, this is a plate, this is a plate. This is equally spaced. Equally spaced means where I put my charge here, or I put my charge here, or I put my charge here, or put my charge here, doesn't matter. It will feel the same amount of force. Basically, because it's a plate. Basically.
Okay.
Right. So equally spaced indicates to you whether you imagine the positive here. I see no line. I see no field line here. Does it matter or not?
No.
It doesn't matter. If you have this, the force you feel will be like that also. If you draw it slightly here, oh, it will be like that also, and of equal strength. The spacing means something. I've covered you almost all the rule of drawing a field line, something like that.
Okay. Oh, the greater the space, the stronger it is.
The what, sorry?
The greater the space between the field lines is, the stronger it is.
Okay. I don't want to say that's wrong or right. I want to say that I want to say what makes a bit more sense visually. Look at the magnet.
So,
you're saying that bigger spacing, stronger. It doesn't make sense visually, I suppose. Right? It makes more sense if it is if it is more lines, is stronger. I guess visually that makes more sense.
Not more lines.
Like if the lines are more packed, so I'm gonna draw lines here, which are more packed but still equally spaced. I can do that, right? See, I'm drawing more lines, but they are still equally spaced, but now it is more packed.
Yeah.
This is my way of saying that, okay, the force is greater twice because it's twice dense.
Okay.
Again, more lines means more force. That's more intuitive, right? Rather than, oh, if it is less line, it's more force. That doesn't seem to fit intuitively, is one thing.
Sure. No, because I was thinking, what if because the space between these is greater, that means they're like repelling each other or something.
Totally confusing, at least because I'm not used to it. Again, I apologize. I'm telling you the agreement with everybody else.
Yeah,
the agreement is what I described in the sense that I hope it makes some other sense. I hope it. I mean, agreement must make some sense. So there's that. Okay.
Why are they equally spaced though?
Again, because in this case, please understand that this is, for example, not a ball. I can charge a ball here and I can charge a ball here. And the lines will look like this again. Why that? Because if I imagine a positive charge, it will be like that. Make sense? Yeah. But once you try to draw the lines on the other side, it will look like that. It looks slightly different already. Look at that. These are the field lines of a charged ball with another charged ball. It's not equally spaced. Look at that. They're not equally spaced. There are more variations between them because this is a ball and this is a ball, a sphere. But this is a plate and this is a plate. So they can be uniform, so to speak, because they are a plate. That's the only reason.
Oh.
Because they are a plate. They are not a curved surface, so to speak.
Sure.
But that's the reason why. Okay, not because it looks nice, not because. Okay, so far so good.
Yeah.
Right, you missed some. I guess you missed the class lah. But for now, this one, get used to it. It's a mixture of agreement, memorization, and also logic. Also. Anything else? Because we are not. If there's anything else, ask on Tuesday. Okay, Michael?
Yeah.
Right. See you on Tuesday, not on Monday. When I say Monday means next Monday. We're going to add the 45 minutes. Okay, right. No, any other question?
No more.
Then as you prepare for mid-year, I hope that you ask even more relevant questions. If you keep asking this kind of question, I don't have to give you extra question. You're already asking the right questions. Okay?
Okay.
Okay, see you on Tuesday and bye-bye.
Okay, see you back.
Oh, wait, no. One more question. Sorry, one more question. I heard background sound when I'm giving you tuition, right? It's like it's very weird. It's like there's another tuition going on in the background.
Is it loud?
No. I mean, it comes in and out because I think the sound filter. Okay. But is it true that they are like maybe your brother or your sister is having another tuition on the same room, something like that?
Yeah.
Is it your? That means Elo lah.
Yeah, but it's just today.
Oh, Elo is also having an online tuition.
Not tuition.
What is it?
Calling with friends.
So what is it? Sorry.
Calling game with friends.
Oh, it's actually game. It's not tuition. It's very weird. Okay, right. Okay. Yeah. No, never mind. It's not too bothersome, but if it does, I'll tell you.
Okay.
Okay. All right. No problem. Okay. See you, Noah. Bye.
See you.